Okay, ladies and gentlemen, we have a sort of an accelerated session here. This is a 35-minute session. We've had 45, we've had 30. This is a one-off, a peek into the future of mobile-enabled healthcare. I'm going to let the speakers introduce themselves. I'm going to get myself out of this. 34 minutes to go, guys. Take it away.
Okay, thank you. Good afternoon, everyone. I'm here, and Gene. I'm Sachin Agarwal. This is Gene. We are from SOA Software. And we are very excited to come over here and talk about three topics that are very, very near and dear to at least my heart. The first one is the future of healthcare. There's been a lot of discussion about healthcare. There's Obamacare, there's healthcare.gov fiascos that are going on right now. It's a very, very, it's a topic that I personally care about a lot. Then it's mobile-enabled. How can mobile-enabled healthcare improve healthcare in general? And then the third one is the glue between mobility and healthcare, which is APIs. That's what SOA Software does. We are an API management vendor, and I'm going to talk about all those three things today. That's exactly the same reason. So if you look at the state of healthcare and what's really is happening in healthcare, if you look at, there's some figures over here, I mean, and these figures are actually a little dated, but US healthcare expenditures are $2.6 trillion. That's the amount of money that's spent in healthcare. It's 17% of our GDP. That's a baffling amount of money that's spent in healthcare. Even more, and so the part that I want to focus on today's presentation is 30% of the spending, 30% of the spending is wasted, $750 billion. So in my presentation today, I and Gene, we are going to talk about how we can do some things with mobile-enabled and API-enabled healthcare to reduce this wastage. So if you look at how IT and healthcare, what are the advances that we have made in IT and healthcare over the last 30 years? There's a lot of advances that have been there. I mean, in IT, we're all from IT. We're here at Cloud Expo. The cloud has essentially changed the landscape of IT, but a lot of things have happened. I mean, we've moved in from mobile devices or desktops to internet to now social conversations. In the healthcare world, extremely, I mean, there have been breakthroughs in genomics. There's a lot of data that's getting generated by genomics. The way the health information is collected, it has moved on from paper-based collection to digital records. The health information system, even your X-rays, your MRIs, these are all getting digitized. There's mobile connectivity, and there's now personal data that's getting generated. So there's a huge amount of data that's getting generated. But still, there are a lot of challenges with healthcare. There's still many hurdles in terms of data lock-in. There's a huge amount of data that's getting generated, but that data is essentially logged in. We are not being able to tap into that data. It's not being able to we are not being able to access it due to security reasons and due to regulatory compliance reasons. So this is, I mean, I go to a healthcare provider, and it's a group of healthcare providers. They recently moved into a EMR system, or electronic medical record system. So all my medical information now is available. It's no longer in file-based records, but it's all electronic. But that system sits in that specific healthcare provider's system. I mean, the doctors within that organization can access it. Once I go out of that network, it's not accessible by anyone. It's not even accessible by me over the internet. I can't access that. So there's this digitization that's happening. There's a lot of IT that's helping internally that healthcare network, but it's not that information is not available outside. So there's no public access to that data. That data is still logged in. And there are various reasons. There's security reasons. It's my private data, or it's the data that's owned by the hospital. They have security reasons. Who can access that data? Is it allowed to be accessed? Is there regulatory or HIPAA compliance? There's all kind of maybe legitimate or complex issues behind that, but that data is not accessible. Then there are electronic health records, I mean, between different providers. That data exists between, so my X-ray information might be sitting in a laboratory that did my lab test. I might be going to another doctor or a healthcare provider, and they have their own electronic medical records, but the two systems do not talk to each other. There's no exchange of data that's happening between it. There are a lot of records. I mean, there's a lot of standards that have come out over the last 3 or 4 years that have tried to solve this problem, but there are a lot of these standards out there, and there's no common way of exchanging data between multiple electronic medical record systems. So that's another big challenge that we need to kind of overcome. And then finally, the most important thing that's what's happening right now, and this is fantastic. I mean, what's happening is there are all kind of Fitbit devices, heart rate monitors, there are weight-taking devices or which connect to an online cloud, and they can send your weight or daily personal health records that I or an individual personally is collecting. And this data is actually, a lot of this data is getting collected. But again, this personal data, which is extremely valuable data, is still not part of the larger healthcare system. The healthcare system hasn't been able to figure out how to take this data that is now going to get generated even at a larger space with all this IoT, Internet of Things, and these sensors. I don't know how many kind of sensors they're going to be around me and in wearable devices on myself. A lot of this data is valuable data. It's going to get generated. But again, it stands alone in its own silos as part of providers, or maybe Fitbit or whatever provider that I'm using. It's sitting in silos. So how do you get all of this together? And this is exactly where APIs come to the rescue of healthcare. So let me take a moment and describe how and why. So first is, what are APIs? APIs have been around for a while. It's an application programming interface. But in its modern context, its current context, what API means is these are RESTful interfaces to your application and services and data. So now you can make your application, services, and data as a company, as an organization, or as an individual. You can make this data available as very simple, open, documented, usable APIs, which can now be consumed in very simple devices like through REST-based mechanisms with JSON payload. A lot of technology and buzzwords over here, but essentially REST-based APIs and JSON, what they do is, like, the payload is extremely simple. It doesn't require a lot of processing, and it makes it extremely easy for devices like mobile devices to consume that data with a mobile device. And that's why mobile-enabled APIs are helping in mobile enabling a lot of application and data that's available over here. This diagram kind of is a representation of that you can take any application, service, or data that you have as an individual or as an organization or as a company, and expose it for consumption in all kind of different devices over here, like tablet, mobile devices, Internet of Things, smartphone, and things like that. So what are the things that are required? How can APIs reinvent healthcare? I'm going to talk about 4 things that are very, very critical in terms of how you can take this data that is logged in EMR systems or personal record systems or wherever it is and be exposed in API. And there are 4 things that are required to be done. One is, how do you accelerate the generation of APIs? The second is, how do you drive adoption of these APIs by developers and business partners so that they can build apps over your APIs? The third is, how do you monetize or license that data? This data is obviously and sometimes sensitive data, personal sensitive records. So how do you really build a model around it so that it's accessible by people who are supposed to access it, and not available to people who we have not made it available to? And then finally, how do you analyze usage of your data? So the first one is accelerate development of APIs. A lot of this data is already sitting somewhere. This data is probably sitting as digital information, digital healthcare records, imaging records, or your Fitbit records that have been uploaded into the cloud, or your heart monitor or Runkeeper records. How do you take this existing data and how do you externalize these existing data in simple REST-based services that can then be exposed as simple APIs for other app developers to come in and business partners to come in and start creating apps? The first thing is externalizing those APIs or externalizing your applications. once you have those APIs, the second most important thing that comes into picture is how do you increase adoption of these APIs? You have an API, but it's of no use if people are not coming in. They don't know if that API exists. And even if they know that API exists, how to use it? And then how do they get access to API? How does it get provisioned to them? How does the security access get provisioned to them? So you need to have a portal where you can go and publish your API, document your API, and do API provisioning. And this is how you drive your API adoption. The next aspect is licensing your API. Okay, your API is getting adopted. It's being used by developers. They're building mobile apps. But there's a licensing model of it. It can be an API to you as an individual, as your health record. But you might not want to expose all of your healthcare record information to a specific developer. You might only want to expose your maybe heart rate information, or maybe your diabetes or blood sugar levels, and not anything else. So how do you put a licensing model over your API so that you restrict access to specific data on top of your the data or API that you have? It could be monetization as well. I mean, maybe in terms of other industries we have seen, it may not be in healthcare, but how do you monetize access to that data? You might have billing, metering on top of it, and you might have a way of just charging for access to your data. There's a lot of clinical trials happening over there in the world, and they might be they might be willing to pay for your information or your data that's out there and put a monetization model on top of your API. And then finally, once your data is out there, it's being used, it's being monetized, you want to analyze that. You want to analyze it in two ways. One is just from an operational perspective. How effective is your API? Is it meeting the SLA? What's the uptime? What's the downtime? Is it being cached? And then more from a business perspective, which aspects of your API are getting used? Where is it being accessed from? Which applications are accessing it? Is it being accessed more from a mobile device or from a desktop application or something like that? So all kind of business analytics that you can do. So that's essentially how APIs can be exposed as REST-based services and then be made available for mobile consumption. And this is where I'll hand it over to Gene. Gene, you can. Is going to talk about mobile devices.
Hi, good afternoon. So I'm going to talk about some of the key challenges that you're going to normally come across. HIPAA encryption, key management in that environment, the high-tech EPHI data breach, security data breach notifications. I'm assuming there are people in the audience that are familiar with some of these topics. Access control and role-based access, mobile malware. In the case of a healthcare application, people could have personal software on their device. They could have some malware, and you need to protect against that. A lot of mobile applications require data close to the user, so we have the ability to help you push data out to the edge. Typically today, depending on where you are in your evolution phase deployment of various things in the organization, people are still moving away from EDI to HIPAA. They're moving from EDI messaging to HL7 messaging, and using integration engines like Mirth, for instance. And when you use that kind of an environment, it does a really good job at data mediation, but it doesn't do anything for access governance. We provide mediation, message protocol, and transport mediation. So, we can do mediation between XML, JSON, JMS, HTTP. We can do mediation between REST and SOAP. There's a lot of projects going on in organizations where people might be trying to create a REST layer with their SOAP application and their SOAP services. In our environment, we can just basically import your WSDL and expose that as a REST service. So there wouldn't really be a need for you to go ahead and build that. Quality of service control. You might have a situation where, particularly if you're an exchange, you have providers, and then you've got doctors and different types of people that are your support people, and you might want to provide different levels of quality of service. You may want to keep track of how often API calls are being made. You may want to keep track of any potential insider threats because of the protection that you need to provide around some of this data and to meet some of the HIPAA and high-tech standards. And of course, usage analytics. We can provide you with usage data, performance data. The typical things that you know when you're in development that you're going to want. So this is really just a visualization of kind of functional areas of the gateway. We have mediation, scripting. You know, we have a lot of built-in policies, for instance, you know, compliance policies, operational policies, QoS policies. And there are times where you might want to create your own policy. You know, taking the insider threat example, right? You know, an insider could be defined as somebody who can authenticate with a system, but still has malintention. So one of the things you could do is write a script and keep track of, you know, normally this API is only called 5 times twice an hour. If you see somebody calling it 500 times in 5 minutes, there's a possibility that there's an insider attack occurring. You could write a script to maintain control over something like that. Orchestration. Orchestration means a number of things, but just to give you kind of a good real-world example, as Sachin was talking earlier, this healthcare exchange data is everywhere. You know, I'm from the East Coast. If I got hurt today, I might get an X-ray in California, and you know, then I move somewhere, and I want to create a continuity of care document that shows all my visits, all my treatments, all my procedures, and it's really, really difficult to pull all that data together. So, you know, what you find is in the back ends of these integration engines, is people are talking to this provider, that provider, out of network, in network, and all to deliver a single API service, an individual patient record. So one of the things that we can do is help you through process modeling, really create a composite service where you might normally have to make 5 or 6 API calls to grab all the data for this particular individual. You know, you're passing the same MRN or medical records number. We can make that one simple call and provide governance over that rather than have to set up governance and policies for all those calls. Security, obviously. We support a variety of security models. We're really security model agnostic. So in most cases, when we deploy in somebody's environment, we'll just adapt to their existing security infrastructure. Lifecycle management. I'm not going to really talk too much about that, but we can also help you with design time and development time governance as well. Help you manage versioning, help you define certain standards, which are best practices that you want your API developers to adhere to during development. Okay, so as I was saying, you know, mediation, we can do things like SOAP to REST. That's pretty powerful. I don't know if there's anybody worth asking for somebody to raise their hands, but in my experience in the past year, I've probably encountered 5 or 6 different enterprises that have ongoing projects where they are converting their SOAP layer to REST. In our environment, you just simply don't have to do that. An example of you know, security mediation would be going SAML to OAuth, something like that. Transport mediation, JMS to HTTP, NetTCP to HTTP. The orchestration, you know, just talking about creating services, you know, from multiple backends that you know, create one simple composite service. It's really what we're talking about here, and then being able to reuse these common capabilities and processes. You know, you might find that every time I create a composite service, I need to go interrogate some system, and I create a service for doing that, and then I can always make that part of my future composite services, helping you gain some reuse. Scripting and customization, you know, I talked a little bit about that. Scripting is one thing. You know, we provide you with the ability to write your own policies. If you don't want to use one of the ones we have, you can write those policies right in line with JavaScript, Bean Shell, Groovy. Very, very flexible. You can do a number of things. You know, I'll give you an example of a script that I recently wrote for another insider threat script. So an insider could be defined again as somebody who can authenticate with the system, but in this case, you know that if you're healthcare.gov, you don't have any subscribers in Sweden. You don't have any subscribers in Ireland. So if you start getting API calls from an authenticated user from Ireland, you might want to block those transactions because you know that person has no reason to enter your system. So one of the things you can do in line here is you can create a policy, you can get the context of the message, and then you can actually look at that message, where it's from, make a call to a geolocation service, figure out what country that IP address is from, and if he's on your block list, you can generate a fault and reject that transaction, or if it's allowed, you can just let that transaction pass through. So it's really, really flexible, the kind of things you can do. The developer portal is a really key component. It helps with a lot of things. As Sachin was saying, you know, API adoption, huge. You know, you've got a place where developers can come, Twitter-like maybe, where they can go check out APIs, choose to follow an API. Those APIs can be set up where they're just open to the public, anybody can use them. You have to grant special access to get them. You can associate license agreements to them that people have to agree to. So there's a lot of flexibility there. But the gist of it really is that they're coming there to gain access to your API. So like for a mobile developer, anybody doing mobile development knows that most of the back-end service we hit are REST services. So developer would come here, you would invite the developer, send them an email, and they'd gain access to the platform. And here they'd see a directory of all your REST services and the operations of those services. So they can get documentation about them. They can interact with the providing group. You know, there's discussion forum boards. There's even defect tracking that you can integrate with that as well. This diagram really just describes and illustrates some different deployment models that we support. First one that we have on the left is platform as a service. You know, you can come to us and we can provide you a PaaS environment, an instance in a PaaS environment. On-premise, probably the most common. We deploy our applications to your environment. Our application, just to kind of review, if you hadn't had the chance to come to our booth, what we do is have a gateway. We have this unified gateway that you see there, and what happens is you register your services with the unified gateway, the physical location of those. We'll then proxy those requests for you, and it ends up giving us an enforcement point where we can enforce all these policies. It also gives us an area where we can collect metrics and a number of other things, right? And then the model on the right is a hybrid model, where you've got part of your environment running in the cloud, part of it running on premises. This is a summary. You know, lower cost, time to improvement, time to market rather, simplify development, provide flexibility, improve the end user experience. You know, I think it's more you're improving the developer experience because the developer is the one who's going to really gain access to your API. Lower risk, speed up development, prevent failure. You know, if you have an environment like this for developers, and you know you're a support organization, you've got 15 developers calling you about a known defect. You know, in some cases, it's nice to have a discussion board where before other people come and report that defect, they can see it there. So, you know, I think that's it. I don't know if we've got any questions or anything like that. But
no.
Thank you.
Yep.
And feel free to come by the booth, and if you want, we can set up a time to give you a demo of an application that is working in this environment.
Okay. Thank you. If there are any questions, we are here or we are in our booth. You can come and ask us over there. Yep.
Thanks. Just leave it here.
So you want some specific use case. So the question is, he wants to talk about us to talk about an use case where the API can be used, and then the cloud architecture can be used to expose that API. So one specific use case over here for healthcare specifically is, I'll talk about the use case that's actually one of the companies is doing. Runkeeper. Runkeeper is a company that uses, or let me switch the context over here. Let me actually talk about Kaiser. A lot of you over here probably know Kaiser as a healthcare foundation over here. What Kaiser has actually done is Kaiser has exposed all of the electronic medical records. As an individual, you can go and access those electronic medical records through an API. So there's a programmatic API. If you have an access to that API, you can go and access that information. Now, as an individual, you don't know how to go and access that API. It's a REST-based API. It's a very simple API, but as an individual, it's still JSON, it's XML, something over there, you don't know how to access it. What actually happens is there are mobile app developers who are creating apps, mobile apps, that can go and access that API and provide a mobile app. So that's where the developer comes in. There's a large community of thousands of developers out there who are just going and creating apps. And they are consuming APIs, not only from Kaiser. When APIs start appearing from other healthcare vendors, they'll just go and pick that API. Now, there's a mobile app that's created. There are mobile apps that you can go and use and start accessing your information. But as a developer, they don't have access to your information. Your information is your information. They should not, as a mobile developer, if I go and access that API, they should not be able to access unless you give permission to that API that you can go and access your information. That's where something called OAuth comes in, which he talked about. Now, OAuth, how many of you know about OAuth, like what OAuth does? I mean, it's similar to what happens in Facebook. So if you are a Facebook user, but when you log in other apps, it says, do you want to log in as Facebook? So you'll see, yeah, you can use my Facebook credentials. You say you allow that. At the same time, that app will say, okay, do you allow that app to access your friend list? Do you allow that app to access your feeds? So there's an authorization model behind that. That's essentially what OAuth does as a standard. So over here, also what's happening is, as an individual, you will give access to that specific app to access your information on behalf of API. So that's where, and that's why APIs, this information, I mean, so the three things that we were talking about in this presentation. One is how can API, like what is an API and how can API help? How can API help to create a mobile app? So it's really, really easy to create mobile apps with APIs because they're lightweight, they're accessible, authentication, access to that data is very. And then from healthcare perspective, since your data is sitting in so many different silos and through the API and through the licensing model and the OAuth model that's created on top of these APIs, it becomes very easily accessible. So you can go to multiple different places, and if they have implemented that OAuth and API authorization model on top of it, that whole information becomes accessible through mobile devices. I think it's still in the early stages, but we seriously believe in the momentum we are seeing in the adoption of APIs in the healthcare world is tremendous. Okay. Okay. Thank you.